I would post an evaluation survey on the platform. Please just go there and do the needful so that at least you can help us so that we can be able to tailor webinars that will actually help create a smooth and a seamless transition as you, a postgraduate, embark on this journey. I see Professor Ivan Hofsajer is already is online, so we will start in the next minute. And once again, thank you all for coming. And I must also use this opportunity to thank the Director of the Academic Development Unit, Professor Rodney Genga, and the Executive Dean and of the faculty and the senior executive team of the faculty for making this thing possible and for granting us this platform where we can actually engage. Today, my mandate is very, very simple. And I think that we will start, and when people join us, then we'll take it from there. I must also say that all protocol observed. I've seen that we have a lot of academics, professors, and lecturers, students, and people even outside of South Africa on this platform. So thank you all for coming, and thank you for wanting to spend this afternoon with us. Having said that, I would introduce Prof. So Prof, I think you can put your slides on whilst I introduce you. Professor Ivan Hofsajer is not a new person to the faculty and to WITS, and as far as the higher education sector is concerned. I mean, he's done a lot of programs on WITS edX, where he's talked about research extensively, and I think that he's the right person to do justice to this topic. And so he is an associate professor from the School of Electrical and Information Engineering at the University, Faculty of Engineering, the Built Environment, WITS University. He's well published in areas of power engineering, all that. But today we're not going to be talking about power engineering. He will be talking to us or be sharing some of his insights and foresights, and I must also say hindsight with us on this topic where it says, is my research science or engineering? Does it really matter? And the answer to that thing is that yes, it does. And having said this, and without wasting time, Prof, over to you, and thank you so much for always being here to support us, and we don't take this in lightly at all. The floor is yours. Thanks.
Excellent. Thank you, Desmond. I will turn on my camera briefly for a moment to say hello. So folk, thank you for being here, attending this webinar. Folk, is my screen sharing okay? We should have a title page on there.
Yes, it's okay.
Okay, excellent. So folk, I'll turn my camera off in a moment. I just want to show you that I am a real person, and I'm busy dodging load shedding at the moment. So I am at WITS at the moment. So all fingers crossed that everything works out okay in terms of the technology. So folk, very welcome, and thank you for attending my idea on for a webinar on Is My Research Science or Engineering? And you can see the subscript there is, this is a tool to navigate this question. So now, folk, the assumption that I'm making is that most of you here are students busy with a piece of research, either a PhD or an MSc or even an honors project, and you are here to get some guidance, get some help, get some advice on completing in good time, because I see completing in good time is becoming more and more a focus of our faculty. Then, folk, further, I'm going to say that my background is engineering, but in our faculty, of course, we have Faculty of Engineering and the Built Environment. And when I speak of engineering, I'm using that term pretty loosely, and it certainly includes our built environment folk as well. So I'm going to use the term engineering, but please don't feel alienated by it. We're in one faculty, and we're all busy with, if I could say this, the artificial, right? The artificial stuff out there, and the built environment is certainly something that doesn't occur naturally. It's something that we generate, and that's artificial. So, folk, what I'm going to do right now is I'm going to turn off my camera after saying hello to everyone, just to conserve some bandwidth, and then we'll dive right in. So folk, what we are going to be doing today is we're going to be looking at this tool to navigate this question of, is my research science or engineering? Right now, what we're going to do is I'm going to introduce to you this engineering knowledge plane, or this map, and you might have already seen this plane on the announcement for this webinar. And I've posted the provocative question about, is our research science or is it engineering? And the one aspect that I don't want to get into with this webinar is the difference between the boxes that people would like to put themselves in of, I'm an engineer or I'm a scientist and I'm doing engineering and I'm doing science. These are boxes that we can put people into, and we can classify people in this way, and we can classify research in this way. But what we're going to discover is that actually there's a little bit of science and a little bit of engineering in everything that we do. And to say that I'm an engineer and I don't do science, that wouldn't be accurate. And even the science folk, if they say, well, I do science, I don't do engineering, that's also not quite accurate, because they are also busy with a little piece of engineering themselves. And this engineering knowledge map that I'm going to show you, and we're going to discuss it, isn't unique to engineering. I've certainly taken general philosophy of knowledge and human behavior, and I've translated it into something that another engineer, that's us, can understand. Because if we go and delve into philosophy of knowledge, the terminology just gets completely out of control, and it doesn't actually mean anything for us as researchers. So what my objective here today is to show this plane, and then to show how it can be useful to look at both the science side of things and the engineering side of things. And we can conceptualize our research in this way, and we can come up with what I think would be a more effective way of going forward and understanding what it is that we actually do in our research. And we could say we are going to, in a way, link science and engineering with each other. Further, I'm also going to say that there are a great many books out there on research methods and research methodology, and that describe the entire research process. And all of those books, when you read them as an engineer and you're busy with your engineering research, and some of you might actually have done that already, when you read those books, they tend to make perfect sense. And it's sort of just obvious what you're reading in those research methods books. But then you try and apply it to your own research, and it just sort of ends up not making sense. So while it makes sense from a pure perspective, how you actually use it is completely unclear, because very often those techniques that they give you in those research methods books, they just don't seem to apply nicely to engineering, and it's almost as if it doesn't fit. And what we're going to do today is we're going to try and link science and engineering, and then you're going to maybe be able to see how all of that stuff that other people talk about sort of fits in with what we do as engineers. Right. Then, folk, secondly, one disclaimer that I'm going to give, and that is something that we always need to watch out for as researchers, and that what counts as good research. Okay, so am I doing good research or am I doing bad research? That goodness of the research is defined by the community where it takes place, right? So I'm going to be telling you a whole lot of things here today, and I'm going to be quite certain that they are correct and that they are sound and that we can accept them. But very importantly, your community where you do your research. And what do I mean by community? Community is the place where other people who research the same kinds of things as you hang out. And you can think of that maybe as your journal where you publish, right? Or the conference that you attend. That's going to be the kind of that's going to be a kind of a place where people like you hang out, and they share ideas and they show each other what they've done. That's the community. And that community, so you can think of it as a journal, they have their own values and standards, and they decide what is good and bad research. And if you're doing bad research in their view, then they just reject you. They say, no, that paper is not accepted. or they say that your paper is accepted because it's good research, we like it. Right, so now my views on what good research is and on this knowledge map doesn't necessarily align with what your community thinks about, because your community isn't attending this webinar. So, folk, I would always caution when you take on board something that you read in a book or that you hear someone else talking about outside of your field, always go and discuss it with your supervisor, and because your supervisor probably is active in the community and can advise on what the community likes and what the community doesn't like, right? Remember, your examiner for your PhD or your MSc is going to come out of the community of experts, and they're going to make the call on whether your research is good or not. So always bounce everything that I say here off your supervisor, and if the supervisor says, yeah, our community likes that, then take it on board. Otherwise, always pay attention to the advice that your supervisor gives you. Okay, folks, so that's my disclaimer. Let's jump in right now and let's get started with this engineering knowledge map. And if we're talking about knowledge, then we first need to sort of understand what knowledge is, right? So now we're going to do this very pragmatically. We're not going to go into philosophy of knowledge here. We're going to just do this very pragmatically. And we've got here a prompt that I have for you, and I'm going to ask you to complete this sentence. Right, so here we've got a prompt of I know. Now, I guarantee you this is something that everyone here can complete, and I'm not going to even ask you to complete it with hectic things, just something that's normal, everyday kind of knowledge, something that you could write down here. And if you're excited, you could drop this in the chat box as well. Just complete the sentence and maybe think about 1 or 2 or 3 or 4 or 5 ways of completing the sentence. The only thing you can't do is over here write I know nothing or I know everything, okay? Because that's a quantity. That's not something you know. So don't write I know everything or I know nothing, but something that you know. And so we've got an I know. I know that I know what time load shedding is for my area. Okay, so thank you very much for that. So there we've got I know. Now, folk, you can think about many different ways of how I can complete I know, but there are only really, and you can list many pieces of knowledge, but there are only really 2 ways in which we can complete this sentence, and we can complete about 98% of the time. The completing the sentence only has 2 forms. Right, and we've seen one of the forms already in the chat box. So now the 2 forms are these: I know and that something is the case. So I know that the sky is blue, or I know how to and an action. I know how to make a cup of tea. So now if we look in the chat about I know what time load shedding is for my area, we could go and reframe that into I know that I will experience load shedding at 8 o'clock, right? So that's a form of I know that something is the case. And the second one we have there is I know the basics about climate change and mining. So we could rephrase that and say I know that the basics of climate change are, and then you could go and list them. So those are both 2 cases of I know that something is the case. And that's if we had to think about carefully, the I know that kind of knowledge, I know that the sky is blue, is knowledge about the state of the world, right? And it's knowledge about what's out there. And we can maybe call this facts, and I'm using this word fact very, very lightly, because fact implies a kind of certainty which we might not always have. But we can think of it loosely in our minds at the moment as facts. It's knowledge about the state of the world out there. Whereas I know how to make a cup of tea is knowledge about changing the state of the world, right? It's about skills and doing. So I know how to make a cup of tea. I've got the skill to do this. And what am I doing? I'm changing the state of the world because before I made a cup of tea, it wasn't there. And now I've done it. So now the cup of tea is present. Okay, so I've changed the state of the world, And we've got these two kinds of knowledge, which pretty much take up about 90% of what we could do in terms of completing the sentence I know. Right, now, carrying on from there, this knowledge about the state of the world, or these facts, they can be written down, okay, or they can be recorded in some way. And we can say, I know that the sky is blue. We can write that down and record it. So this is knowledge that we can record. I know how to make a cup of tea. I said is skill knowledge, and we can't write down the skill. We can only demonstrate the skill. And we need to be a little bit cautious here, because I might say I can write down a list of instructions for making a cup of tea. That's certainly something we can write down. And then I could complete the sentence. I know that the steps of making a cup of tea are, right? So there's knowledge about the world, and that's a recipe, okay? But having the recipe does not necessarily mean that I have the skill as well, right? So I might have the recipe for making a cup of tea, but I cannot execute that recipe. If you're now thinking, how is that possible? Then we can just push the making a cup of tea action to something more complicated, like playing the guitar. And I might say I've got a book that describes how to play the guitar, and I've read the book. But do I have the skill then of playing the guitar? No. I've read the book. I know all the steps, but I can't actually execute it, right? Because the skill knowledge is something that resides inside me. So we've got these two kinds of knowledge. The stuff that can be written down, the facts, and we've got the doing knowledge. That's the skills. And these are our two classes of knowledge. And we're going to now represent these two classes of knowledge on our on a two-dimensional plane. Right, let's go have a look at it. So here we have a two-dimensional plane. We've got a horizontal and a vertical axis, and they are at 90 degrees. That 90 degrees is important. These two things are orthogonal to each other. Right, and saying that these two pieces of knowledge are orthogonal to each other is something the philosophers absolutely cannot grasp, because they do not know about orthogonal planes in the same way that we do. But in any case, we've got on the vertical axis here, we've got knowledge about the world. This is knowledge about the state of the world. This is, I know that the sky is blue. I know that we're going to have load shedding at 8 o'clock. That's knowledge about the world. And on the horizontal axis, here we've got our skill knowledge, the knowledge about how we make a cup of tea. This is the knowledge that resides inside of us. Now, from an engineering perspective, we might go and call these two things investigation, right? We do an investigation when we want to know something about the state of the world. We want to know what's out there. And when we want to change the world, we do a design, right? We say, well, this is how you have to put parts together to bring about some kind of an effect. And I use the word design here to incorporate, let's say, design of physical things like a machine or something like that, but also to design something which is non-physical, like maybe a piece of software or a process or something like that, which isn't actually going to lead to a physical artifact, but it's putting together of parts, right? That's how I'm using this term design at the moment. Right, so we've got these two kinds of knowledge on these two axes, and let's go look at the gradings of these axes. So on our design axis, we're going from procedural knowledge, right? In other words, we know exactly what's going on with our design. We can do it sort of with our eyes closed. It's very, very simple, and we do it all the time, all the way out to open-ended, where we actually don't know how to do this. We might not have any idea, and we'd actually, if we encountered the design problem, we might even wonder and say, no, we can't do that. We don't know how. Okay, we don't have the skill to do that, right? So from very easy to really, really tough. Then on the vertical axis, our knowledge about the world goes from certain to uncertain. Now, what do we mean by certain and uncertain? We need to just unpack a little bit what we mean by this. And because we've got this grading that goes from something that's well known to something that might not be so well known. So how do we categorize our knowledge about the world? And we can do this in several ways, and I'm going to give a whole bunch of examples here about how we might understand the certainty of knowledge. So what we could do is we could say, well, we've got established knowledge, and that might be certain or more certain than new knowledge. So let me give you an example here. Established knowledge, let's think about something like Newton's laws. These are established, they've been around for a long time, and we've got a reasonable certainty that those laws are actually okay. And we can accept them and we can use them and we don't really question them. However, on the other side, we might have a new paper that we just encounter. And the new paper is reporting that by adding some kind of nanoparticle to a coating, the reflectivity of the surface becomes better, right? So now that's a very new piece of knowledge, and we might say that we aren't certain that that is correct. And definitely we would say that this new knowledge isn't as certain in our minds as Newton's laws, right? So we're a little bit more uncertain of this new knowledge that we have just encountered. And even from a research perspective, we might want to say this new knowledge that we've just encountered about these nanoparticles and this coating and its reflectivity, we might want to go and verify it. And that might actually be a research project. However, if we're down at the bottom here and we say, let's go and verify Newton's laws to see whether they are okay or not, then probably that won't count as research. Everyone will laugh at us. Okay, so in terms of certainty, established knowledge is more certain than new knowledge. Okay, that's one of them. The next one is we can think of concrete things are more certain than abstract things. Okay, now what do I mean by that? Let me give you an example. Let me give you a concrete example. It could be that we go into the laboratory and we mix some chemicals. We have a chemical reaction going on. And we measure very carefully the heat that's being produced. We measure the masses of the reagents, and we come to the conclusion that the mass has remained constant and that the energy has remained constant. And we can say we saw that in a physical experiment. Okay, so that's very concrete. We can be quite certain of that. However, in an abstract form, we might want to say there's this law that says conservation of mass and conservation of energy. And that's a little bit more abstract because that isn't a physical experiment that showed it. It's just this general purpose law that's out there. And it's a little bit more difficult to understand that law than it is to understand the actual concrete experiment that's taking place right there on the bench. Right, so we can say the concrete experiment that was taking place there on the bench, we could call this empirical. That's more certain than the abstractness of a physical law that's out there, because we can visualize this concrete experiment very much more easily than we can this abstract concept. Right, then we've also got, when it comes to certainty and uncertainty, we've got a single case versus a general case. So a single case, let me give you an example. I might say that I am reasonably certain that I am right-handed. Okay, it's a single case. I can quite easily say I'm certain about that. In general, I could also say that the students at WITS are 85% of them are right-handed. Now, that is less certain in general than my single case, because I know for certain I'm right-handed, but I cannot place the same certainty on the general claim that 85% of the students at WITS are right-handed. And then lastly, we can say that things that are known to me are more certain than things that are unknown. And of course, this is quite obvious. So folk, these are 4 ways of thinking about the certainty that we have of knowledge about the world out there, right? So this is a way of thinking about that certainty and how we might grade the certainty of knowledge about the world out there. Now, on this vertical axis where we have knowledge about the world and which we're calling investigation, this is very often what, and I use this term very loosely as well, what scientists like to keep themselves busy with. They like working with the world that's out there, right? So this is the science kind of axis. At the bottom here, we've got design. This is where we tend to like to say, this is where where engineering and technology resides. Okay, we're designing stuff and making stuff. But my contention here today is that we always need the science, the stuff about the world, the knowledge about the world, before we can actually go and do design. Because we can't go and change the way the world is unless we understand the way the world is. So for us in engineering, I'm making the case today that we're going to need the science, we're going to need to know what's out there, and we're going to need the skills of to say how do we go about things? How do we go about changing the world? How do we go about doing? So now the classical view is this is science and this is engineering, and I'm saying no, we need both. And I would also make the contention that if you're a scientist and you say, I normally worry about what's going on in the world, you certainly need to know a bit of engineering as well, because you are going to need to do things. You're going to have those skills to do stuff in the course of your research. So now I'm not going to concern myself too much with what the scientists do. We're looking at engineering, and in engineering, we're going to need both of these things. Now, we can define research and normal engineering in this way. And now we're getting to that picture that you've already seen before, and this is where it came from. So now when our certainty of knowledge about things out there and our ability to do the actual actions are somewhat known, then we can say we're busy with normal engineering, right? So normal engineers, they solve difficult problems all the time, and normal engineers work on things that are unseen, right? So we don't always have procedural stuff. We've got stuff that's uncertain and we're not sure about it, but we don't do radically uncertain things as part of normal engineering. As part of normal engineering, our doing and what we investigate about the world are sort of under sort of reasonably certain most of the time. So we're reasonably certain most of the time that we can achieve things, and that's normal engineering. As the uncertainty increases in what we're doing, right? So we don't know how to do this out there, and we don't know what's going on out there with the knowledge. Then we start entering into the realm of research, right? So this is not normal engineering. Here we're going past normal engineering, and what defines that? The uncertainty of what's going on, and the I don't know how to do that part becomes larger. Then we start entering into this realm of research. And as engineers, let me just say as well, we sometimes need to do the investigation and find out about what's going on in the world, because we can't always leave it up to the science folk, because they might not have done the science already, and we need the science. And then we can't wait for them to do it, so we go out and do it ourselves. So in that sense, we're busy doing some science, or we might be doing some engineering, or we might be doing a little bit of both. So now, this engineering knowledge plane is what I'm contributing to everyone this evening. Now, this engineering knowledge plane is not something that I've created myself. This is knowledge this plane, this understanding of how knowledge works has been out there for a long time, and its roots go all the way back to Aristotle. But what I've done is I've drawn this picture, and I've tried to make sense of what's going on in this picture from an engineering point of view. And we're now going to go and have a look at how we might be actually able to use this going forward. And the first very simple thing that I'll point out as we see how we might use this going forward is these two axes lend themselves naturally to different kinds of activities. So on the vertical axis, where we are talking about the state of the world, what's going on, I know that kind of knowledge. We ask questions. What, where, why, how much? When is load shedding going to happen? What are the basics of climate change and mining? I can ask questions quite easily about the state of the world, right? Not so much about the doing and the skills. There we normally have objectives where we say, I would like to design or solve or develop something. So we've got questions on the vertical axis, we've got objectives on the horizontal axis. Now, that's already going to feed in directly into when we talk about research questions and research objectives. And we're going to unpack that in a moment. But before we do that, let's just go and have a look at two examples of using this. And here's our first example. So in our engineering knowledge plane, we have a research question. How does a heat treatment process affect the hardness of a new metal alloy? Right, so this is a question about the world out there, right? It's about the hardness of the new metal alloy. So it's knowledge about the world. And we can say, well, we don't know. This is a new metal alloy, and we don't know what's going on with this heat treatment process. And we can say the uncertainty of the knowledge about the world is high because this is brand new. However, the procedures that we're going to use to measure that hardness, that's well known. We can go into the lab, we can give it to a lab technician maybe and say, go and measure the hardness of this alloy before and after the heat treatment process. So in this sense, finding out, the actions of finding out are quite procedural. Okay, and we might actually say this procedure is the scientific method. Okay, I'm using scientific method here in inverted commas because the scientific method actually means a great many different kinds of things to different kinds of people. But broadly speaking, it's a defined method, and it's useful for finding out about the world out there. And we would probably be using one form or another of the scientific method to figure out what's going on with this alloy and its hardness. But in any case, we're probably measuring in a standard way. And we can position our research out over there and say, well, our knowledge isn't about changing the world. It's not about design. It's about characterizing the world and characterizing what's out there. So that's one example of using this knowledge plane. Second one is we've got something out here on the horizontal axis, the design axis, and our objective is design an algorithm to sort apples and oranges on a conveyor belt with a low-cost vision system, right? And that's unknown. We don't know how to do that because let's say the low-cost vision system hasn't got a lot of computing power, and we need to come up with a really simple way of doing this. And let's say that's our constraint. We can't spend a lot of money on the system, but we need this algorithm, and we don't have that algorithm. So our research is now coming up with that algorithm, which is unknown. So how to do this, we have absolutely no idea. We're going to need to apply our engineering skills over here and our design skills to come up with something. However, we're going to be using standard components, right? We're going to not be trying to worry too much about uncertainties in the world out there. We know what a definition is of an apple and an orange. We know about the conveyor belt. We know about the vision system. We know about computing power. We know all of these things. That's all pretty certain there. And we just need to go and say, I need to do the design, which is coming up with the interrelationship of all these parts to achieve something. And we might call that also the engineering method, right? Because why? That's engineering method is pretty much saying I've got a specification and I need to achieve the specification. And this webinar is now not about the scientific method versus the engineering method. Those are two things you can go and Google, and you're going to find a whole lot of pictures just on flow diagrams showing you the differences between scientific method and engineering method, and you're absolutely welcome to go and look at that. We're not going to unpack those two things now. Okay, so using these two approaches, okay, these two approaches where the work is and the knowledge that we're dealing with is focused on the axes, right? Here they are. Now, here we've got a very important departure on the different kinds of knowledge. Here we've got the heat treatment process, and it's independent of the researcher, right? So whether I do the heat treatment process hardness measurements or someone else does it, we should be getting the same results. So on the vertical axis, knowledge is independent of the person who does it, right? On the horizontal axis, that's not the case. On the horizontal axis, the knowledge is directly related to the skills of the person doing it. So if we're developing that algorithm to sort apples and oranges, then the success of that algorithm or not depends on my skill, right? And my algorithm will be different from yours, and your algorithm might be performing better. in whatever way better we could, in whatever way we might define better, but it's dependent on our skill. So knowledge here is not absolute, and it's not the same kind of independence as we have on knowledge on the vertical axis. Okay, so those are two quite important differences, and that leads to the concept of the hypothesis. And I'm just going to throw this in now because I see this being used very incorrectly a lot of the time. So on the vertical axis, because we are dealing with knowledge about the state of the world, a hypothesis is okay, right? So our hypothesis might be the hardness increases after the heat treatment process, right? So that would be a hypothesis, because a hypothesis can be true or false, and it's a statement about the world. So using a hypothesis, if you are doing something on the vertical axis, you're worried about the state of the world, and you are asking a question about the state of the world, then normally our hypothesis is quite okay, and you can go and verify whether that hypothesis should be accepted or rejected, right? So we can go and test that hypothesis because it's independent of the person doing the work. Now, on the bottom side, where a lot of engineering research lies, we're trying to come up with something to change the state of the world, right? The algorithm. Now a hypothesis is not relevant. It's not okay. So if we think about that algorithm to sort apples and oranges, then the hypothesis is not okay, because we might state the hypothesis of it is possible to develop an algorithm to sort apples and oranges. Okay, and that's certainly a statement that can be true or false, but the trueness or falseness of it depends on the person doing the work, because it could be that I have this as a research objective, and my hypothesis is it's possible to develop an algorithm, and I spend some time on it, and I am not able to develop that algorithm. Then I need to reject it and say it's not possible to develop an algorithm. But that was only because my skill was insufficient. And someone else could come along and say, oh, I've done this algorithm, I've made it. And then all of a sudden this hypothesis statement becomes true, and it becomes acceptable. So now we've got this hypothesis which is accepted or rejected based on the person. And of course, that's not a good hypothesis. So my contention here is, if you're working on this horizontal level, then you do not put in a hypothesis in your work, because it's actually a statement about your skill. And you are saying, actually, with your hypothesis, I'm pretty good and I can develop this. And of course, we don't want to know about you. We want to know about the algorithm. So you wouldn't want to put that in as a hypothesis in your work. Okay, so folks, I'm just mentioning that because I see this hypothesis being pushed in places where I think it might not always be necessary. Right, then we've discussed now what happens on the vertical axis and on the horizontal axis. But now we're not always working there in these nicely defined boxes. We might be working in this other space out here, and that's normally where the exciting stuff is. So let's go have a look at that. Okay, so here we've got, we're down here now. Here we've got our research space, and we've got a research question, which is complicated. And here we've got a very practical problem, and we're asking the question, why is this tall building struck by lightning, but this other equally tall one not? So let's say we're in the city, and there's the two buildings next to each other, and they pretty much both the same height, and the one is always being struck by lightning, and the other one isn't. And of course, we'd like to know this because it could lead to some kind of understanding, so that we can build better lightning protection systems for these buildings. Right, so now this is about creating understanding. Right, we're looking for why something is the case. We're trying to build some understanding, and we might do this through a model, right? So we might say, I would like to create a model of this lightning striking this building, and this will help us understand it, and we're creating meaning, right? So now that's often where the really nice, exciting research is, and it's where the big contributions can lie. But we run into problems when we start creating meaning. And that is because we have to create, right? So we have to make something that previously wasn't there. So how to do that is sometimes difficult. and what are the things that we need to know about the world in order to create that meaning, we're also not entirely sure about that. So we've got uncertainty about what should we go out and find out about the world, what should we measure, what parameters should we even be including in our model, and how should those parameters be arranged? How should we design that model so that we actually have our objective met, which is creating understanding? So now we're in the middle over here where we've got two sets of uncertainty. And I would almost like to say this is the nice spot where PhD kind of work lies, because here you can create a nice kind of contribution, because we're expanding knowledge tremendously, because we're creating that new model or that new understanding. Okay, folks, so what we've gone through so far is this knowledge plane and how we might use it to position ourselves and what we are doing in our research. Now, what I'm going to do is I'm going to now take this tool and I'm going to run through a quick application of it. So let's say, and I'm making some assumptions now about where you are with your research, and let's say you're at the you're busy trying to unscramble the proposal stage of your research, and you want to have some help on how do I go about putting this research together? How do I go about conceptualizing things? And we're going to run through that very quickly now. Although if you have already passed the proposal stage, you probably still will find this quite useful, because it might be refining your understanding about how this knowledge and how your own research is being put together. But in any case, folks, when we start using the tool, I'm going to ask you to start with a very simple exercise, and what you do is you just write my research is about. And what you fill in over here, my research is about, this is probably a paragraph. You just write about your research in natural language, right? That's very powerful. Use natural language because you understand natural language. Don't use fancy jargon. If you are using terms from your field, that's okay, because you know what they mean, but don't start using fancy research methodology kind of terms here. Just talk as if you were talking to someone, your friend, your fellow student, what your research is about. And you describe what your research is about. You don't dumb it down, okay? You don't make it, you're not talking to a general lay person. You're talking to another expert, one of your colleagues, one of your fellow students, and you're explaining what your research is about. Okay, you write that down. Write down a paragraph. Depending on how far you are with your research, that might even be an entire page. Right, so you write down my research is about in natural language. Okay, then you go and you unpack that paragraph that you wrote down, and please write it down, because if you don't write it down and try and do this in your head, you miss a lot of stuff. So then you identify every possible question and possible thing to do that's coming out, and you look for the whys, the whos, the whats, the how much, the how long, to what extent. Those are probably words that you were using in that paragraph, and you look at the things to do. These are the doing things: develop, derive, show, build, make, create, solve. Okay, so you identify those things, you build a list, make them make them visible. Then you ask yourself, do I know why, who, what, or don't I know? Do I know how to develop, derive, show, or build, or don't I know? Right, so if you do know these things, then okay, then you don't really have much of a research challenge. But most of the time there'll be things that you don't know, right? So now if you don't know, that's a good start for a piece of research. However, you not knowing doesn't mean we don't know. Now, who's we? We's the community. So when you say I don't know how to, let's say, develop a model, then that means you don't know, but you have to ask the community. What is the community out there? Do they know? And how do you ask them? You go and read the literature, right? And they're quickly going to tell you, the community out there, through the papers that you read, that they actually do know, or no, you can't find anything. Then you can turn your I don't know into a we don't know. And the moment you've got a we don't know, now you're cooking. Now you've got a piece of research that's important. because just you not knowing means you might need to go and learn it because you don't know about it yet. You need to go and read the book. But we don't know means the knowledge doesn't exist, and now you can go and start formulating that research. Then you ask, are these questions and doings interlinked, or is say answering the how much something that you don't know or we don't know, but to find out isn't too difficult, right? So then the doing is quite easy, and then the questions are not interlinked. The interlinking words, which sometimes you can find, the interlinking indicators are model, interpret, apply, create, understand. These are the things that normally require both vertical axis knowledge about the world and horizontal axis doing, right? Design knowledge, because these things have to sort of be, it isn't a standard procedure to do any of these things. And what the parts are that need to be combined with this also isn't normally visible. So then what do? We go and take this list of stuff that we've generated, and we go and place it on this engineering knowledge map. So we see what are the things that we don't know that's out here. This is a boundary out here. The I don't knows are inside here, but it's stuff that's general engineering. So probably for your research, this is stuff that you're going to have to do. Okay, this is stuff that you need to do to be able to deal with the bigger picture, but it's probably not going to be your research questions. The stuff out here where we've got the huge uncertainty, that's where we're going to find our research. So we can just go and point that out now. So we've got our research questions, which are the we don't knows. That's going to be out here. And the I don't knows are things that I need to go and find out, right? I need to go find out, and I'm going to look it up. I need to go and read about it. I need to go and do some searching in the library or searching online. But these are things that I don't know, and it's going to be necessary for my research, but probably it isn't a research question, right? The research questions are the stuff that we don't know, and that's out here. Then on the horizontal axis, we've got something similar. The stuff that is not too difficult, the stuff that would be normal engineering, the doing, that's your methods and your methodologies. So those things are normally moving into the methodology section because it's the actions that you are going to carry out in the doing, right? The things that we need to do, which we can say we don't know how to do that, those are then your research objectives, right? So now we can see what are research objectives and what are just standard things that we have to do as part of executing our research. And that normally goes to the method and the methodology side of things. Okay, folks, so that is, okay, so that is coming back to our big picture here. That is an overview of this engineering knowledge plane that I've shared with you this evening. And folks, you can now go and ask yourself, is this valuable to me? Is this helping me understand better what my research is about and how to position myself and what might be appropriate and what might be not appropriate for putting my research together? I've combined the science side of things here, and I've combined the engineering side of things here, let's say the classical science and the classical engineering. And I'm saying we as researchers in engineering, we work all over the place depending on what it is that we need to actually do and what the nature of the research is that we have to execute. And for that reason, our methodologies and how we go about doing our research is often not standard, and it's often not we're not following a classical approach. So certainly in most of engineering research, we never really bother ourselves with things like, are we using a qualitative or a quantitative approach? Whereas the science kinds of people, especially in the social sciences, they go absolutely crazy about, am I qualitative or quantitative? And these are very important things for them to unscramble. Most of the time, those kinds of things for us in engineering just aren't even questions that we worry about. Why? Because we're operating everywhere in this research plane, and we're using knowledge from everywhere, and we construct our research in the way that makes sense to go forward. And that's how we act and how we operate as engineers. So now maybe this engineering knowledge plane has given some additional insight into why we tend to always have custom pieces of research and they don't follow any kind of pattern. This is why, because we operate everywhere on the science and engineering knowledge plane. So, folk, that's all that I have for you this evening. I would certainly like to have discussion on this. If you think this discussion this plane, this map that I've presented could be useful for you, it might need a little bit of unscrambling in terms of taking some time to figure out what is it exactly that I've been describing here and discussing here. But I certainly think this can be useful for conceptualizing your engineering research and putting it all together. And I think this could also be useful if you are, say, reading a paper from somewhere else, and you can fit this paper and the parts of the paper that you're reading onto this plane, and you can see where contribution lies, where foundational material lies, where previous research that might be in a background section is coming in, and how all the knowledge is being dealt with in the paper that you are reading. Okay, and then of course it might help you in writing your own paper as well. So folk, that's what I have on this knowledge map. As I say, this knowledge map is not something that I've dreamt up myself. The foundations of this are human behavior, right? Knowing about the stuff that's out there and being able to do things. And that's come since sort of human beings started being active as human beings. I've just put an engineering face onto it so that we can use it from an engineering point of view without having to go and first do a degree on philosophy or a degree on sociology. Folk, that's what I have, and thank you for spending some time with me this evening and listening to me. So Desmond, I'm done, and I would encourage discussions on this if there are anyone. Desmond, I don't know how you want to do this. Should folk just put their hand up or unmute themselves, and then we have some time for discussion?
Thank you so much, Prof. I think that folks can just shoot their hand up, and then we have the discussion from there. And I think that this is a great opportunity to also, I think I see a lot of academics here. It's also interesting to note that maybe you should pass on the message to your students, because we designed this thing specifically for them, but most of them don't attend it. And they would pick 1 or 2 lessons from here, because this year, the drive of the faculty, as per the dean, is that student must finish in record time, and also student must be seasoned, and student must be well disciplined, and also have a broader understanding of what the research process is about, the research map is about, and how they can now use that as a tool to guide them in what they are doing. So it's very, very important. So Prof, I think if anyone have anything to add or something, we just shoot our hand, and then we can take the conversation forward.
Right. Oh, Desmond, while we are waiting for any questions, and indeed I do see some colleagues here, and colleagues, thank you for spending some time here with me, and colleagues, I certainly think that when it comes to research in engineering, we don't have a good foundational background on what engineering research is. So we certainly do things and we achieve success going forward. And we've got a lot of skill and a lot of experience, and certainly engineering research goes forward, and we make great strides. But for students starting out, it can sometimes, I think, be a little bit bewildering. And our students here can talk to me about this, that the foundation of what I should be busy with or how I should go about this is often not easily accessible, because from a foundational, let's say theoretical research point of view, we don't have a good framework. Whereas in the, let's say, the pure sciences and the social sciences, they've got very rigid frameworks, and there are books on how to do research in social sciences from one side of the library to the other side. There's just tons of them, but there's nothing when it comes to engineering. And I certainly think that we need to have some kind of a framework in place, even if it is just this kind of framework, maybe expanded quite significantly, to get students started in the right direction. And certainly the supervisor's got a role to play there, but this could relieve a little bit of the burden on the supervisor to not always be having to do the foundational theory of this is what research is, and do it via sort of an osmosis kind of approach, where this kind of structure is already in place, and then the supervisor can build on that structure and say, well, this is where our research is, and this is how we go about it in this field, because certainly every field is different. But I definitely think that we need some kind of a framework or structure to scaffold the research process going forward.
Prof, there is a hand up. Errol, go for it.
Can you hear me?
Yes, we can. Carl, please go ahead.
Yes, I'm actually busy with a PhD proposal in the mining engineering side. I'm actually looking at developing a transition framework for climate change for the mining industry. And what I realized is before you get to a framework, you actually need to go and find a lot of information. And what I've done is I've identified 4 areas that I need to know much about. It's like transition, governance, impact of climate change, and mining. And actually, if I know all those information, then I can go from the I to the we. And because I think then in the we is that there's no transitional framework for climate change and mining, and then that can address it. Because I think a lot of times it happens that you design something in the I thing, and then already it stays I and it doesn't go into we. So I actually liked a lot, because even now you take all that information is to start designing a framework. It's a lot of work on the end of the day to address the I thing, but I think it's good that, because I said to myself, because I'm on study leave, I said to myself, there's a lot of things I don't know, and if I know all those things, then slowly you get into your thing. But the thing with policy is you don't get specific data, so you need to go and do. I want to go and do 10 interviews.
Okay, Carl. So Carl, what I'm hearing is that you are on this research plane. You are solidly
and out of those interviews, you can actually see what you don't know and what you do. So out of those interviews, maybe mostly that go between the I.
So sorry, Carl,
yeah,
I think I lost you there
when you
for
go
a
from
moment.
I to we. Yeah. Now, what I was saying is, I want to go to 10 mines and do interviews on the framework. But I think then we need to go and say, okay, when you go outside that known area to the research area, I think that we thing is actually quite important. But you do have to do a lot of work, because I think in my cases I have to do a lot of work in those 4 areas. Plus, I need to go and find out in the mines what did they know. So then we can say, okay, where do we go with the we thing? And I think that is where I think that's where your model actually kicks in very well. But thanks a lot for the presentation. Okay.
Carl, excellent. And I see your research is being right out over here, because you've got to develop this framework, which means you have to make something that previously wasn't there, and how that might be, we don't know. And also, what are the things that you're including? So you're reading up on those 4 aspects, but inside those 4 aspects, what is it that you're going to include? That might also be a little bit uncertain. So you are, if you tell me you're busy with a PhD, then I would say you are positioned exactly right for your PhD.
Thanks. Yeah. Okay.
Right. Thanks, Carl. So Nish, I see your hand is up as well.
Thanks, Prof. Great presentation. Thank you very much. What I wanted to find out is there a modification to this diagram or a transfer function between engineering knowledge and scientific knowledge, because some of our work that we do borders or straddles between the two. And it's very difficult between writing a research question versus a hypothesis based on whether or not you are doing engineering work or scientific work.
Okay, so my framework over here does away with the need for that distinction. So we've got some research objective, some overall big thing out there, or let's say some research aim or some research goal or some big super question that we need addressing, and it's going to have different parts. So there's going to be a part that we need to know about the world, and we might call this scientific knowledge, right? Because certainly what we would like is that the knowledge about the world is correct. And we're going to use and pretty much the scientific method is focused on eliminating errors. Okay, so the scientific method in all its incarnations is about, I haven't gotten it wrong, I'm not fooling myself, and my knowledge about the world is something I can accept. It's something that I could call is accurate. So there's our scientific part. And a hypothesis is one of the tools that we have to go about creating that knowledge about the world, right? So we might have a question and we're asking something, for example, what happens with the hardness of the metal alloy, and we want to answer that question, and a hypothesis statement and a hypothesis testing is a way of generating that knowledge. So we might say the hardness increases, and then we go out and test for the increase in hardness. So a hypothesis isn't necessarily always a requirement, but it is certainly a useful tool sometimes in the scientific process to get the knowledge which we could call scientific. However, the design stuff is very, it's sort of doesn't, we're not happy to say design and the process that we've come up with or designed is unscientific. We sort of, it doesn't feel right to say that, but it doesn't meet the strict requirements always for science, right? Because it's a creative thing. It's something we created, something we came up with, and we balance these two things against each other. So sometimes we're doing the investigation side of things, sometimes we're doing the science, and sometimes we're doing the design, which is sort of the more classical engineering-y kind of thing. And we're combining these two in whatever way is appropriate, and we're going to use the tools of design, which is going to be our objectives, our making, our creative stuff when we need it, and we're going to use the science stuff, which is the which is the objective stuff, right? It's the non-creative stuff when we need that as well. So I would say we balance these two things against each other, and we're not really going to transfer science knowledge into engineering. We use the two approaches in whatever way we need to deal with the overall research that we are busy with. So Nish, I know that hasn't answered your question entirely, but I would say we're not going to transfer it. We are doing one piece of research, but certainly we're approaching it as engineers. Right, so the usefulness and the application and all of that kind of stuff is going to be really important for us. Not that I say the scientists don't think that's important, but for us it's sort of the primary driver, the usefulness of this. So Nish, I hope that's answered your question to some extent.
Yeah, okay, that makes sense. Thanks, Prof.
Right, and we've got another question here, Aaron. Your hand is up, please go for it.
Hi, Prof. Thanks for the presentation. Prof, my question is, you mentioned from the framework that you're proposing here, it seems the objectives are more towards when you're developing the research objective, it falls more towards the unknown side. Whereas, I don't know if I captured you well, because that's what I seem to pick up. When maybe your research objective that you're developing, they should be more aligned toward what we don't know. But then most of the times, at least some of the past research that I've read is that it will be that some of the objectives that they've developed, it moves from the known to the unknown. I'm not sure how does that sort of relates to what you've sort of put out here in your framework, Prof. Thanks.
Okay, Aaron, if I understand you correctly, let's just go one back. Let me see if I can go one back here, where I was talking about research objectives. So now certainly, okay, so good question. What is a research objective? And if you've got this section in your proposal document, or maybe your final document, what should you include in research objectives? So now sometimes objectives, what does the word objective mean? It means something we want to achieve, something we have to do, right? So and there's some deliverable that comes out of that after the doing. Now, certainly we might say our objective would be to let's say, get hold of all the materials, right? Because let's say we need to build some experiment and we need a lot of materials to do that, then certainly getting hold of the materials is an objective. But that isn't a very complicated objective, because that means I just need to go and order the stuff and I need to select the right materials. So as a research objective, it isn't really an unknown thing, but it's certainly something that has to be done. So you might want to say that I've got this objective of getting the stuff and it's on my to-do list, right? It's on my to-do list and I have to tick it off. It has to happen. Otherwise, I'm not going forward. But I wouldn't necessarily say that that's a unknown thing, so that you would call it really part of your research objective, something that's really going to be a contribution. You wouldn't be able to say one of my contributions is to knowledge is that I got the stuff. That wouldn't be valid. But you could say that I came up with some new framework or new model or something like that, and that output is indeed a research objective. So it depends on how you want to define the objective and the research objectives. But certainly I would say if you're putting together your proposal, then you would just describe it. So I'm always open for and I always encourage it. Describe things so that there's no misunderstanding. So if you say I've got these following objectives and I've got 10 of them, and these like 8 objectives are simple ones, because it's the simple objectives, it's the building, it's the making, I need experiments, I need to go out and do all these things, and these are objectives that are going to have to be met. But I also have another objective, which is a tough one, which is I could call it a research objective, which is going to actually produce a piece of new knowledge. And then you can say that's my research objective, and my other one are maybe just procedural objectives. But they all point to things that I have to do. So now very often the procedural objectives, you sometimes drop into the methods, because if you're saying I need to go and design this experiment, and that means of course I need to get the materials, and then sometimes getting the materials finds its way into the methods where you describe what you're going to do, but sometimes it's actually still in the objectives. It depends on how you are describing things. Aaron, did I understand that question correctly?
Yes, Prof. Thank you. It's very clear.
Right. So folk, when it comes to terminology, I would always advise describe what you mean so that it becomes clear. Because sometimes what's the difference between an aim and an objective? It's not always clear. So then you don't use those terms. You just go out there and you say, this is what I mean, and you describe it in natural language. So I'm a very big fan of natural language, because one of the biggest things that we encounter with our research is other people don't understand us. And we've gone out and we've done this amazing stuff, and to us it's incredibly clear, and I go out and I explain to someone else and they just don't get it. And at that point we fall flat. At that point I'm lost, because no one can understand what I've said. No one can understand what I've done. And then I say, let's rather go and explain it in the absolute simplest way possible, so that the other folk out there can understand what I'm doing. And then I get my message across, I get the point across, and then someone else understands what I'm doing. And then if I'm doing something wrong, they can sensibly tell me I'm doing something wrong. They don't just tell me, oh, you're no good, because why? Because you didn't explain properly. I would rather know that I'm doing something materially wrong, because why? Because the person I was speaking to understood what I was doing and they managed to point it out correctly. That is actually pretty valuable. If I just explain something and it turns out that they misunderstood me, and then they dismiss me because I didn't explain nicely, that's always terrible. So I'd always advocate go for the simplest possible explanation. And if there's a chance that someone's misunderstanding what you mean by a term, explain the term. For example, we haven't gone into what's the difference between a method and a methodology. And I'm very certain in engineering, these two terms are being used incorrectly. But we're not going to get into that right now. So I'd almost say you don't use even these two terms, methods and methodologies. You say, this is what I'm going to do for these reasons. Then you don't need to worry that you're getting this word methodology wrong. But okay, we're not digressing into a lecture on terminology.
Prof, I think that this will also be an opportunity to talk about the GOLD program, since a lot of people have sent that, have received the email, but I think it's also be a good platform since a lot of these things will be expanded on the GOLD program. Thanks, Prof.
Okay. Excellent. Okay. So Desmond, yeah, if I need to talk about the GOLD program just for a moment. So there's in terms of research and postgraduate support, of course, there's the program that comes from our academic development unit here in the faculty, and that's Desmond, right? So you see Desmond there. Desmond is the one doing the postgraduate support in our faculty, and Desmond's arranging a whole lot of webinars and a complete program on topics that are useful to support postgraduate work, and that's in the faculty. So that's very much focused on engineering in the built environment. But then there's a greater program that runs across the university, and that has that is run by the Postgraduate Affairs Office. And if you just go to the Postgraduate Affairs and you just type in that and you Google that on the WITS site, you're going to come across the Postgraduate Affairs Office, and they run some programs as well. And one of them is the GOLD program. And right now, you put me on the spot if I know what GOLD stands for, but it's all about the graduate development work. But what they do is they do a whole lot of these kinds of lectures, some of them on campus, some of them online, and it's on all kinds of topics to do with research. So sometimes it's simple stuff like how do you reference correctly and how do you use the library, and sometimes it's about how do you write a good abstract, how do you go about writing a good scientific report. There's writing retreats. It's across the entire university, so all the faculties are involved, and you can go and attend any of these lectures or seminars or webinars. It's for free. You just sign up for them, and I would encourage you just to go and have a look at the program. Just go and have a look at the program. You'll find it if you Google Postgraduate Affairs at WITS, and you're going to come across that GOLD program, and it's going to be a spreadsheet, and there's tons of these little bits and pieces of support throughout the year, and some of the lectures are repeated quite often, and just see if there's something there that interests you and sign up for it. As I say, it's completely free. It's a service from the Postgraduate Affairs Office, and you might find some stuff is quite useful there. I certainly would advise as well, and this might sound strange, that when you start looking at things like how to construct a good argument, then there's a lot of good courses and seminars from the non-engineering faculties. So let's say coming from the humanities, right? How to construct an argument. Now, the humanities don't have math as a tool, so they've only got language. So where we tend to rely on math and say the math will carry us through, they don't have it. So their argument structures have to be absolutely rock solid. And often going and listening to what they have to say about something like argument is a really good idea, because they do it incredibly well. So I normally go and listen to their kinds of webinars and their kinds of lectures when it comes to that kind of thing. How do you set up a good argument? How do you write something in a good way? How do you communicate effectively? They certainly have a lot of interesting stuff out there, and I'd encourage you to go and find it, and do not be put off by the fact that it's coming from the English language department or something like that. They are very, very well suited, and you'll definitely learn a great deal, even if you go outside of our faculty.
Thanks so much, Prof. Anyone who wants to ask some questions, or any academics that want to also contribute to the discussion. Like I said, this is a safe space where we come to dialogue. So anyone, and I've also put the link to the evaluation of today's webinar. So please go ahead and rate the webinar and tell us what are the areas that we can get the right people to help, so that at least you can, the idea is to make sure that you have a seamless process to be able to go through your postgraduate studies and finish record time. Very, very, very important. Any more? Okay, let me use this opportunity to make the following announcement, and then Prof can give us some parting words. In 2 weeks' time, that's the 4th of May, we are going to be having another webinar that will be hosted by us. But Professor Imote Palagidede will be talking to us about finishing your degree in record time, some tips and techniques that would come in handy. A lot of the things that we do as far as these workshops and webinars are concerned, I tell people, is common sense, but it's not commonly practiced. So a lot of the things you've heard, which seems to you as I know this thing, but it is your ability to do these things and to use these tools is what is actually going to make a difference. It is very, very unwise to know all this stuff and not being able to implement them to make sure that you finish your degree in record time and also get some papers published, get your name out there, get your name into the community so that people can also say that, okay, we know that one. I think his voice counts as far as the community is concerned. So I think that the flyer will be out this right after the webinar. I think by 6:30, you should receive emails and you should see. I mean, he's one of the prolific professors as far as the VIT is concerned, and from 2016 to 2021, he graduated over 27 PhDs. I mean, these are people who have gone on to become associate professors. Some of them have gone to win several awards nationally and internationally. So, I mean, like I said, we try to bring people that have walked the talk, not people who can only blow hot airs but have nothing to show forth. So it is very, very important that you glean knowledge from some of these people that have done it. They've been there, they've done it, they've shown that it can be done. And so that gives us the joy and the ability to know that if somebody have done it, then we can also do it. So please watch out for that webinar, and we're looking forward to it. And then the following 2 weeks, we'll have a webinar that we've titled Publish or Perish. It's very, very important that whatever good work you've done, you are able to communicate it effectively so that people can also see that, okay, there's some good stuff coming. So please make a date with us and go to our ADU postgraduate support site. We have about 3 years of data and things over there that you can use. And most of the lectures and webinars that Prof. Hofsajer has also presented on various aspects of research, engineering, problem solving, and all that, they are all there. And go there and listen to some of them, glean knowledge, and be armed with the right stuff. In this era that we are in now, nobody's interested in your ability to regurgitate stuff, but people are interested in your ability to use the tools, the resources, and the knowledge that you have to be able to change the socioeconomic challenges that we face as a continent, as a nation, as a world. So please go there and try as much as possible to see how much you can. If you don't have access to that site, please send me an email, drop me an email, and then I'll make sure that you are added to the site so that at least you can also be part of the conversation. I might also say that our community of practice website for the honor students, the masters, and the PhDs, it's nearly done. And once it is done, I would invite you to join it. It will be a platform that I'm calling Idea Factory, where we come there to engage. We come there to look at things that we can do to go forward. The last announcement that I want to make is that we've noticed that a lot of our postgraduate students are actually owing fees here and there. We are coming with Little Drop of Water campaign, where we are trying to say that, can you pass on that 50 Rand, that 20 Rand, so that collectively we can help support people that don't have the means to finish. There are people who are in the third year of their PhDs and probably they need about 20K or 30K to be able to finish. This is a community where we can support. And what the way we are trying to do this is to start from within. So we'll start from the faculty, we'll start from, then we'll go to the university, then we'll reach out to our alumni, and then we'll reach out to the broader society out there. But charity begins at home. So please, in the next few days and weeks, you will be receiving a formal communication from the office of the executive dean. So we hope that you would participate, and then you can contribute. That will be a fund that we'll use to support people, to make sure that at least we are providing a cushion for you, so that once you also become an employer, you will be able to extend that hand to our people. We are talking about postgraduate, making VIT a postgraduate intensive or research intensive universities, but these are some of the little ways we can collectively contribute. If I asked one person to give us 20K, it's going to be a lot of challenge. But if 200 people can come together and each of us give us 50 or 100 bucks, collectively, we can make up that thing. I think these are some of the ways we want to try and see we can support each other. And also, thank you so much for coming. Prof, I now want to hand over to you so that at least you give us your parting words, and then we can, I think we have 7 more minutes. So over to you, sir.
Right, thank you, Desmond. I don't think we're going to need 7 more minutes unless there are any other questions. What I would say to everyone is I want to see you at graduation, and I want to see you at graduation in the not too distant future. And I look forward to that. And hopefully our graduations will be in the Great Hall again, and it's going to be a fantastic party, and it's something to look forward to. So folk, all the best with your research, and certainly attend these other seminars that you've just heard about. They certainly sound exciting and very, very relevant. So folk, all the best for your research going forward, and I hope to see you at that graduation. Desmond, that's all from my side, and I think we can perhaps then call the webinar to an end.
Thank you so much, Prof. On this note, I want to use this opportunity to first of all thank our speaker, Professor Ivan Hofsajer, who is always ever ready to be here and share his wisdom and experience with us. And I also want to thank the director of the Academic Development Unit, who has through the office of the Dean of the Faculty of Engineering that have made this thing possible. And also to thank all of you. I see my bosses here, Dr. Emmanuel Ojo, thank you for coming. I think that Professor Extel and Professor Herman and others have actually left. Thank you so much for coming. And I'm looking forward to seeing you in 2 weeks when we will try and look at another set of webinars. And on this note, have a wonderful evening, and please keep safe, and I will see you in 2 weeks' time. But on that note, please send me emails, whatever we need to talk about. Let's take the conversation off and then talk about emails. Send me emails. You know where to find me. I'm in the Chamber of Mines. Just come through. Let's see how we can help you so that you can get this degree, get this edge, and use that certificate to do a lot more to help so that we can solve the socioeconomic challenges we face as a continent. On this note, thank you so much for coming. I'll see you in 2 weeks' time. Bye for now.